Alex. I appreciate it. I'm actually doing this, just so everyone knows, I'm doing this from Lima, Peru, which is where I am right now. So it may have some obstacles as we go. If my phone cuts out, I'll for some reason I'll do my best to phone in again. Anyway, just going to take you through the presentation today, focusing primarily on cool white reflective roof systems. It is one of the roof systems endorsed by the Clinton Climate Initiative. So I'm going to start off just by taking you through some quick things about my company, Tremco, RPM, the Building Solutions Group, as well as some introductory roofing type knowledge base that you guys will need as we move forward. So I'll just begin by giving you guys a quick definition of sustainability. This was given by the United Nations World Commission on Environment and Development. Defines sustainability as sustainable development meets the needs of the present without compromising the ability of future generations to meet their own needs. So that's just kind of the framework that we work within when we talk about sustainability here at Tremco. So we're just talking about high-performance buildings. What should a high-performance building do? High-performance buildings should reduce negative environmental impact, should reverse the trend of unsustainable design and construction practices, reduce operating costs, increase the service life of the building, enhance the building's marketability, and improve occupants' performance and attendance. So that's just kind of what we're looking to achieve when we try to make a building a high-performance building. So again, talking about the high-performance building, these are just kind of some of the elements of the building envelope we try to address when we try to transform a building from its current state into a high-performance building. So, you know, the HVAC, air control, and interior air movement systems, vegetated roofing, the air barrier system to improve air quality, glazing transition systems for efficiency, daylighting, obviously waterproofing, drainage systems, the exterior cladding for insulating the exterior of the building, seamless floors. I'll be honest, I don't know a whole lot about, not my specialty, but deck coatings and membranes, again, for waterproofing purposes to improve the durability and longevity of the building. Renewable energy systems. I know Tremco Roofing and Building Maintenance does a whole lot of work with rooftop solar PV. And then finally, cool roof systems, which is what we're here to discuss today. So the RPM Building Solutions Group, again, Tremco, one of the companies, part of this larger group of companies called the RPM Building Solutions Group, which encompasses Tremco Roofing and Building Maintenance, Tremco Commercial Sealants and Waterproofing, Canadian Building Envelope, Euclid Chemical, which specializes in additives for concrete products, and then Dryden Systems, which specializes in exterior cladding, insulating systems. We're a publicly traded company on the New York Stock Exchange, and I just have our sales there in the bottom right.
You are now muted.
Of the size of the company, and to let you know that we are a substantial sized company, and this is important just for, I've found it in my dealings, just for the purposes of warranties. We're a company that actually does honor our warranties, and that's kind of it's been shown and reflected upon by our growth over the years. So, and again, talking about the high performance building here, what we're here to talk about today is the roof, and in particular, cool roofing systems. So just some quick roofing facts for you. Roofing represents less than 10% of the cost of any building, but it is an issue in roughly 80% of all construction litigation and 10% of all professional liability claims. So for the most part, you know, most people don't think of the roof until it's leaking, usually on their desk. That's kind of the first thought they give to the roof. But it should be noted that it is a vital component of the building envelope, as is evidenced by the fact that it's a factor in 80% of construction litigation claims. So definitely don't, you know, the roof is often out of sight, out of mind, but we're trying to keep it in the forefront of our minds here as we move forward. So I'm just going to take you through the various roof system types, the most common system types available in the marketplace here in Ontario. The first being single-ply roof systems. These are your EPDMs, PVCs, TPOs, TPAs. Usually a very low initial cost to quick installation. We don't. There are some problems with ply redundancy when it comes to installing these systems, because you do just have the one waterproofing layer, so they are not resistant to tolerance. And again, with just the one waterproofing layer, we don't see those layers of waterproofing that we would ideally like to see in a more robust system. There are problems with the seams. These systems are rolled out. So on a large roof system, you literally have miles and miles of seams, which is a potential problem area for water infiltration. These single-ply systems are intolerant to ponding water. Any ponding water can work its way through the system, through the seams. Single-ply systems cannot be restored, and they have generally an 8 to 20 year life expectancy. 20 years being at the high end. We don't generally see single-ply systems lasting for 20 years. And I believe my phone is having some issues right now. Let me see here. I'm just going to go on to the next slide, and there's a good chance the battery on this phone is going to die as we move forward. With the 2-ply mod bid system, we see two plies of redundancy. So where the single ply had one ply of redundancy for waterproofing, the mod bid system does have 2 plies. So a little more robust system. We've got usually a factory surfacing on the top ply. Because there are 2 plies of waterproofing with the factory surfacing, you do have a little more resistance to abuse and foot traffic than you would a little better than the single ply. The 2-ply system is maintainable. There is possibility for restoration usually involving an upgrading of the top pour, a new flood coat, and the seams. There are issues with lap integrity in the seams, similar to a single ply. Because these systems are rolled out. You do have some blistering. Usually it's a matter related to the installation. The 2-ply mod bid system generally has a median life cycle cost, and they do last generally in the neighborhood of 15 to 25 years. The next system we'll talk about is the built-up roof system. This is your traditional kind of asphalt and gravel system. Generally 3 to 4 plies of waterproofing redundancy. There is a true waterproofing element with the interply asphalt between the plies. The built-up roof system is highly maintainable, very easy to maintain, great possibility for restoration. Again, redoing the flashings and putting on a new top pour and flood coat. These systems with the aggregate embedded into the top pour are extremely tolerant to abuse and foot traffic, so generally not a problem with foot traffic and abuse on the roof. The top pour eliminates any seams, the types of seams that you see in single-ply and 2-ply mod bid systems. So you do have a fluid type top pour for waterproofing purposes on the top ply of the roof system. Now, because there are 3 or 4 plies of waterproofing redundancy, there is a higher initial installation cost. But we do generally see longer life cycle from a built-up roof in that 20 to 35 year range. So there is, in fact, a lower life cycle cost associated with the built-up roof. And then finally, there are a number of hybrid systems available in the marketplace. The one I just want to touch upon is in an inverted assembly. So whereas traditional roof systems are built up from the deck with insulation and then the waterproofing on the top, an inverted assembly you have the waterproofing directly on the deck, usually a concrete, which allows the waterproofing elements to remain on the warm side of the deck, so you're not exposed to the cold temperatures in the winter. So this particular system allows for dual waterproofing, usually a fluid applied membrane with a single ply adhered directly into that liquid rubber, and then built up from there with insulation and any type of ballast on top, whether that be a green roof system or patio stones or river rock. Very easy to install, generally cold applied with low odor. It does require a concrete deck. Again, ideal for vegetated roofs. Low life cycle cost, despite the higher cost of materials, because it is easy to put down. There is a lower life cycle cost because you generally see between 30 to 50 years of life expectancy. this is a slide I just wanted to share with everyone, and I do actually have this slide later on in the presentation. It just shows the average roof membrane life expectancy. This is information that came from the widely discussed study called the Carl Cash study. You can just see the various roof system types and their average life expectancy. So you've got, in the light blue bar there is EPDM, a single ply, average life expectancy of 14.2 years. CPE, another single ply, 12.8 years. PVC, another single ply, 14.1 years. MB, that blue bar is a two-ply mod bit system, 15.9 years average life expectancy. 22.5 years, the yellow bar there, that's the built-up roof system. The green bar there is sprayed-in-place polyurethane foam. We don't see a whole lot of that going down. As you can see, it's less than 12 years for an average life expectancy, and then 25 years on the metal roof system. Most metal roof systems are sloped, so that's the reason you see that longer life expectancy. You don't have water sitting up there. But I think this slide is very telling because you can see all of those single-ply systems have an average life expectancy of less than 15 years, and they don't offer any possibility for restoration. So when we're talking about true sustainability, in the roofing industry, we like to talk about durability, and having to put an entire roof system into the landfill after only 15 years is not, in my opinion anyway, not true sustainability. So we like to look towards the longer lasting systems like that two-ply mod bit system and the built-up roof system. So moving on to talk, what we're here to talk about primarily, which is cool white reflective roof systems, and in particular the Tremco rocket system, which has been endorsed by the Clinton Climate Initiative. So what are the benefits of white reflective cool roofing? Obviously, reducing the cooling load is the primary kind of benefit. When you've got a white surface up on the roof, you don't have that heat emanating from the roof system, so you don't have those high surface temperatures that you would customarily see from a black type surface. So as a result, you are improving the energy efficiency. You don't have that heat transfer through the building. You also don't have the air intake units up on the roof working as hard as they might be if you have the warm air emanating off of a black surface. So you really are improving the energy efficiency of the building. Reducing the thermal expansion contraction of the roof. This is actually a big one when we talk about the longevity and life cycle expectancy of the roof. Dark surfaces, they heat up to high temperatures during the day, and then they cool off at night. And like anything else, they expand when they're heated up and they contract when they cool down. By minimizing the amount of that the roof is heating and cooling, you're reducing that thermal expansion and contraction, which will reduce the wear and tear on the roof, and ideally it will increase the roof longevity. And then finally, reducing the urban heat island effect. When you don't have the heat emanating off of these dark surfaces, you are eliminating a lot of that urban heat island effect that heats up the cities that we live in. And I've got a slide a little later on that will show an example of what the urban heat island effect actually does. And this is a quick slide, a result of a study done at the Oak Ridge National Laboratory in Illinois. This is a study which aimed to show the fluctuation in roof temperatures over the course of a day. So you can see this is a study that was conducted. These are sample readings from the first month of installation of having these various roof systems installed. So you can see if you look at the chart on the left, that black line is an exposed black EPDM roof system. And you can see the massive fluctuation in temperature as the day goes on. The roof surface heats up to over 140 degrees Fahrenheit, and then cools down to below 40 degrees at night. So just these massive temperature fluctuations. The blue line there is a bare white TPO. So that would be a white single ply. You can see it's significantly cooler than the black system, and then the other systems are inverted systems, and it's kind of testing the temperature of the roof surface ballast, whether that be stone or pavers. Now, it's important to note this sample temperature reading was taken after 1 month, and this is a study that was conducted over 3 years. So I will show kind of the follow-up graph as we go on which shows kind of how these temperatures and these differentials change over time. These are some temperature readings that we took at the University of Toronto, Scarborough campus, just a day in late August, not overly warm, 27 degrees, sunny day. We had just installed our rocket roof system, this white built-up roof system at the University of Toronto, Scarborough campus. And I'm not sure if anyone is familiar with the U of T Scarborough campus, but they kind of have every available roof system, seemingly in the world seems to be on this campus here. So we went up there with an infrared thermometer device and just took some temperature readings within the span of 5 or 6 minutes here. And as you can see, look at that white rocket roof system, the surface temperature being 33 degrees. They had a brand new light gray mod bit system whose reading came in at 42 degrees. They had an old traditional built-up roof system, which is that asphalt and gravel system, came in with reading 47 degrees. A brand new dark mod bit system came in at 62 degrees. And then an old exposed black EPDM system, which came in at 72 degrees Celsius. So just kind of a massive difference there in the temperature readings on the roof surface at the University of Toronto. As I mentioned, the urban heat island effect, if you can see Atlanta there, the chart on the left, they call it an urban heat island, and this I think goes a long way in explaining why it's called an island. It isn't actually an island of heat there, the city of Atlanta. Just if anyone's been to Atlanta, there's a lot of asphalt, a lot of blacktop, not necessarily a lot of green space. So the result is you've got this warmer kind of climate in this little island of an urban area. So when we talk about white roofs, we just want to stress the important considerations with regards to Sorry, my phone keeps beeping here. With regards to mitigating risk, as the Carl Cash study showed earlier, those single-ply roof systems don't have the type of life expectancy that we'd ideally like to see when we talk sustainability. So you really do need to consider the durability of single-ply roof systems lasting anywhere from 8 to 15 years, 20 years at the high end. Another important consideration is the appearance of the white system. Primarily the color, the white color, and the reflectivity are not included in the warranty, and as a result, planned preventive maintenance is critical. Again, I just go back to this slide here when we talk about mitigating risk, the importance of the average roof life expectancy in those 3 single-ply systems all coming in at under 15 years. Just want to stress the importance of that. So again, getting back to mitigating risk, this is taken from that same study at the Oak Ridge National Laboratory in Illinois. Some of the conclusions drawn. The surfaces of white thermoplastic roof systems lose between 30% and 50% of their reflectance after 3 years of exposure. So, that is very significant. If you're putting down a white system and it's going to be losing, up to half of its reflectance within 3 years, these are factors that need to be considered. And then this, again, taken from that same study, a graph which just highlights the decreasing reflectance of single-ply membranes over time, over the first 3.5 years there. So these single-ply membranes, these white surfaces, do get dirty. The soiling of single-ply membranes caused by climatic exposure is significant because after only 1 to 3 years of field exposure, the highly reflective membrane has a surface temperature that is only 12.5 degrees Celsius lower than that of a built-up roof system. So again, that built-up roof system up in the high 40s. If you're putting down a white single-ply system because you believe it does have cooling properties, 1 to 3 years, and it's not all that much lower than a built-up roof system. Just things to consider, particularly when we factor in the life cycle of a single-ply system. So again, how reflective are these surfaces? You can see these white these white single-ply systems and judge for yourself how white and how reflective and how cool they are. So again, just this is one of my favorite quotes from the study regarding the white single-plies. The results show that certain roof materials will require washing to meet the EPA's Energy Star criteria, reflectance exceeding 0.5 after 3 years of exposure. To me, I can't really think of anything less sustainable than having to get up on your roof and spray it with clean chlorinated water just to get it clean so you can severe Energy Star criterion. So, and again, the major drop in reflectance usually occurs within the first 2 years, or first 2 years of exposure. So again, this is that same study at the Oak Ridges National Laboratory. The first slide I showed was 1 month into the experimental program. This is 19 months, so just over a year and a half. And again, you see that black EPDM with the massive temperature fluctuations. But what is interesting to note is that blue line, that bare white TPO. After a year and a half, you can see that there are 3 systems, inverted systems underneath the stone that actually come in at cooler temperatures than the white TPO. So that just kind of echoes the idea of the roof system getting dirty within the first 1 to 3 years and being less reflective than, you know, something as simple as a paving stone, which you can see came in at a temperature lower than that white single-ply membrane. So what is the answer to this type of conundrum where you've got these white single-ply systems that don't last as long as they should, and that get dirty and that lose, you know, 30 to 50% of their reflectance within the first 3 years? Well, to us, the answer was to create a white built-up roof, because the built-up roof is the type of system that gives you that long life cycle and that durability. And if you could, you know, get the surface of that system to be white, then you kind of have you'd have an answer to that problem. So the rocket roof system offers that white aggregate and top pour, which will stay whiter longer than a single-ply system. It's funny, if you ever get up on a built-up roof, when you see the aggregate up there, the stone, you don't ever notice it being dirty. And I think that's because stone has a way of somehow being self-cleaning, that the water tends to wash the dirt away. So this system does stay whiter for longer than a single-ply system. Being a built-up roof, you've got that top pour, which eliminates any seam problems that you would get in a single-ply system. You do have that ply redundancy, whether it be a 3-ply, 4-ply, 5-ply build-up roof with the white top pour and white aggregate. And again, the 3 or 4 plies offer true waterproofing, the thermal performance coming from the insulation. Again, the built-up roof system being highly maintainable, easily restorable, and, you know, factored in with the white surface and the redundancy and the life cycle and durability, it offers what we consider to be true sustainability. So I'm just going to take you through a couple of sample kind of successful applications here in the Greater Toronto area. The first being, you know, you can just kind of see for yourself the photographs here. The City of Toronto Solid Waste. This is an installation done in 2010. This right here, part of the Project Green Bayer. Locally here, this roof was installed last year in the winter of 2010. Brilliantly white, highly. This is a system that should be in place at Bayer for many years to come. Center for Addiction and Mental Health, downtown Toronto here. That installation done in the spring of 2009. This was we lost this file here when we were transferring it over, so I apologize for not having the photograph. That was the University of Toronto Scarborough campus. Moving on, Ennis Clare Centre in Oakville. This was about 140,000 square foot job we did. Actually, interesting story. There's a kind of high-end condo not far from the Ennis Clare Centre, and between that condo and Lake Ontario is this particular this building with the white reflective surface. And so shortly after we'd done this installation, the condo corporation actually had filed a complaint with the Ennis Clare Centre saying that the roof was so bright and the reflectance so much that it was actually obscuring their view of the lake, which we thought was, we were hoping we could get somehow in writing, because pretty amazing that the roof surface could be that reflective that it would, you know, the glare would be obscuring their view. So pretty amazing project there at the Ennis Clare Centre. This is Toronto Community Housing, their head office at Yonge and St. Clair in Toronto. They've actually installed a 10 kilowatt photovoltaic system up on this roof system, on this rocket roof system. It's important to note that I guess one of the benefits of having this particular white reflective system under a solar PV array is that the panels are actually more efficient when the backside of the panels is kept cool as opposed to being hot. So having this white reflective roof surfacing system beneath the solar PV array will help keep those efficient. So a nice kind of complementing piece of the solar puzzle there. So some of the other significant rocket roofing jobs we've done here in the GTA include the Bank of Montreal, Royal Bank of Canada, Toronto Transit Commission, which actually has the rocket system as their spec. Any kind of re-roofing job they do from now on goes with this particular rocket roofing system. The Union Station revitalization project, renovation project, they've got a huge green roof, also by Tremco, and then the remaining roof is rocket. City of Toronto has done a number of installations. The Regent Park redevelopment, I know the aquatic center there, which is kind of the center of that redevelopment project, has got this rocket roof system. Ryerson University, the Regional Municipality of York, Humber River Regional Hospital, and the Ontario Realty Corporation, just to name a few here locally. Just to take you through some sample economics of the cost involved in putting the rocket system on any roof. I guess I should note that this particular top pour, or the white cold applied top pour with the aggregate, can go over either a mod bit, 2-ply mod bit system, or a built-up roof system, and it can go on either a new project, whether it be new construction or re-roofing, or a restoration project as well. So if you've got a 10 to 15-year-old roof that is in need of a little bit of work, one of the answers might be to do a restoration project, which would involve the rocket roof surfacing system. So the premium for the rocket top pour and aggregate versus straight asphalt, straight asphalt is extremely cheap to put down. So the upgrade premium is anywhere from $2.50 to $3 per square foot. Compared to an upgraded flood coat, when I talk about an upgraded flood coat, I'm talking about a rubberized asphalt or cold applied top pour. The premium is anywhere from $1.50 to $2.50 per square foot. When you factor in the Clinton Climate Initiative discount, that brings the price down a little bit. So versus straight asphalt, the upgrade upcharge either $2.12 to $2.55 per square foot versus the upgraded flood coat. You're looking at $1.27 per square foot to $2.12 per square foot. And then when you factor in the Clinton Climate Initiative discount with the City of Toronto's Eco Roof incentive, that brings that cost down even further. So versus straight asphalt, $1.62 to $2.05 premium, and versus an upgraded flood coat, 77 cents to $1.62 per square foot premium. I guess a safe rule of thumb, I mean, every project is different, but a safe rule of thumb is to say that kind of most white built-up roofs come in at roughly a 5 to 10% premium, with some pricing actually coming in lower than traditional asphalt-based flood coats. So we have actually done some projects where, factoring in the discounts and the incentives, you come in cheaper than a traditional built-up roof. So it's worth kind of having the discussion if you're doing a re-roofing project to see where we might be able to find you some money to get this done. We think of, as I mentioned earlier, mod bit systems and build-up roof systems as being slightly more expensive than the single plies. But when you look at the overall life cycle cost, factoring in the length of time that roof is going to be on your building, these particular systems, the blue and the yellow bar, come in at a lower price than most of the single ply systems. So when we talk sustainability, we want to think about the life of the building and the life of the project. So what are some of the incentives and programs available for Cool Root? Obviously, what we're here to talk about today, the Clinton Climate Initiative and Partners in Project Green Purchasing Alliance offers up to a 15% material discount on that rocket roof surfacing product. The City of Toronto's Eco Roof Incentive Program offers 50 cents per square foot as an incentive for any rocket roof that's put down. And then BOMA Conservation and Demand Management Program, the CDM program, offers $800 per kilowatt in annual energy savings. And then I would also highly encourage you to check out the Cool Rexdale program through Partners in Project Green. That they're doing some fantastic things in the community with bringing in local youth from the community to work on these roofing projects. It really is an amazing program they have going. So just I want to leave you with one final thought here on the rocket roof surfacing system. In 2008, specifiers using our white rocket roof resulted in 128,000 less barrels of oil being needed to complete the square footage. It's quite a significant number, and we expect that number to double in this year, 2011, because we are putting a great deal more of the rocket system down than we were in 2008. So, aside from saving you guys some money and giving you a better roof system, we're actually using a whole lot less oil. So it's kind of a feel-good story using this rocket system. Just to touch on a few more of the sustainable roofing options that we do here at Tremco. Done a lot of work with the rooftop solar PV here in Ontario.
You are no longer muted.
Assemblies, we've put down over 1 million square feet here in Canada, more than any other roofing manufacturer in North America. So just some other options to think about. We do offer a whole range of preventive roof maintenance items, as well as interior air barrier upgrades for energy savings. So with that, I will leave you with the contact information here. To learn more about the Clinton Climate Initiative, I would encourage you to contact JT McLean, and to learn more about other incentives and our Tremco kind of cool roof and sustainable options. I would encourage you to contact either myself or Dennis Braun from the Toronto Region Conservation Authority and Partners in Project Green. So I want to thank everyone for their time, and I apologize for my phone. I don't know if you could hear the beeping on your end, but it was somewhat distracting on my end here. But thank you very much for your time and for your participation, and I think